Welcome to the Unit 2 of Apparel Production Management. In this unit, we will be studying about production and productivity. In this unit, you will learn about basic concepts of productivity and its measurement methods. This unit comprises of 2 modules and a final review section that invites you to reflect on what you have learned. The 2 modules being Module number 1, Basic Concepts of Productivity, and Module number 2, Measurement of Productivity. By the end of this unit, you would be able to review basic concepts of productivity, examine the effect of productivity on standard of living, differentiate between production, productivity, and productive efficiency, measure output and input, classify and calculate various types of productivity, outline how productivity is lost, review examples from the garment industry to illustrate concepts. Let us first get into the first module, that is Basic Concepts of Productivity. The first module, we will learn about the basic concepts of productivity, which includes need of productivity, productivity level from country to country, productivity and the standard of living. What is productivity? Productive efficiency, measuring output and input, and finally, communicating productivity. Let us first try to understand the definition of production. The action of making or manufacturing from components or raw materials, or the process of being so manufactured. The processes and methods used to transform tangible inputs, which includes raw materials, semi-finished goods, sub-assemblies, and intangible inputs, idea, information, knowledge, into goods or services is what is referred as input production. The term may refer to a range of human activity from handicraft to high-tech, but is most commonly applied to industrial production, in which raw materials are transformed into finished goods on a large scale. Such finished goods may be used for manufacturing other more complex products or sold to wholesalers, who in turn sell them to retailers, who then sell them to end users and consumers. As we know, the growing international competition has put lot of pressure on apparel manufacturers to produce quality products at the competitive price and deliver them to the customer just in time. In this scenario, manufacturers of apparel industry will need to lead the factories to the path of continuous improvement. The improvements also need to be measured continually. In such a case, productivity data can be a useful indicator of the level of performance of the factory. Productivity is also one of the most frequently encountered words in management discussions and in economic debates. Notwithstanding its popularity, productivity is not generally fully understood by many. Productivity level differs from country to country. China is emerging as the leader in labor productivity in cotton, textiles and garments, with labor productivity almost double that of India and Vietnam. India lags behind the competing countries because of very strict labor laws as compared to countries like China, which in turn impacts overall labor productivity. China's labor policies are perceived as more employer friendly than India's labor policies. As a result, there are reported issues of long absenteeism from work, lower levels of efficiency in work, dearth of new skills people joining the industry, and other issues which impact overall productivity of the labor force. Another reason lies in the composition of Indian workforce vis-a-vis the competing countries. Strict laws which stop women labor to work for late hours in the night, even if they are willing to do so, further hits the productivity since the overall working hours of the factory are cut short. Next we come to productivity and standard of living. Productivity and standard of living directly affect each other. Standard of living may be described as the amount of material well-being necessary for a person or community to sustain and enjoy life. The increase in the standard of living can only be achieved if a person or community is employed or it is producing goods or service that generates income and wealth. There are basically two ways in which the standard of living can be improved. They are increasing employment or increasing productivity. Higher productivity can contribute to a higher standard of living as it will provide large supplies of consumer goods at lower costs and lower prices. It will also lead to higher real earnings and improvements in working and living conditions. To achieve any increase in productivity, a country should have a balanced program for economic development. Steps to maintain employment should be taken. Opportunities for employment should be created for those who are unemployed or underemployed, or those who become unemployed as a result of productivity improvements. Let us try to understand the definition of productivity. A measure of the efficiency of a person, machine, factory, system, etc. in converting inputs into useful outputs is productivity. Productivity is computed by dividing average output per period by the total costs incurred or resources, which would include capital, energy, material or personnel consumed in that period. Productivity is a critical determinant of cost efficiency. The formula for productivity percentage is output divided by input into 100. I repeat the formula for productivity percentage is output divided by input into 100. Output of garment factories can be pieces of finished garments. Output of the department within the garment factories can be meters of fabric inspected in fabric inspection section, cut components in cutting room, washed pieces in washing section, number of garments ironed in ironing section, and so on. Examples of input are man hours, machine hours, meters of fabric consumed, or electricity consumed. Let us take a very simple example as shown and try to calculate productivity in both these cases. As we see in the example, input in both the cases is the same time, that is 1 minute. Output of first case is 158 pieces and of the second case is 200 pieces. So, by putting the values in the formula of productivity, productivity of the first group is 158 pieces per minute and the productivity of the second group is 200 pieces per minute. Now let us try to understand productive efficiency. In simple words, productivity is concerned with the efficient utilization of resources, that is the inputs, in producing goods, that is the output. Efficiency is the ratio of actual output attained to the standard expected output. The concept of efficiency is closely associated with productivity. Quite often, productivity is expressed in terms of efficiency. For example, if the standard expected output per operator is 25 pieces of jeans per shift and the operator productivity is of 20 jeans per shift, the productivity in terms of efficiency will be calculated by the following formula, that is, the actual output attained divided by the standard expected output. In this case, it would be 20 divided by 25, that is equal to 0.80 or 80%. This expression may be also called as productive efficiency. Now let us try and understand the various approaches of measurement of productivity. There are mainly two approaches to the measurement of productivity. These are partial productivity measurement and total productivity measurement. Apparel manufacturers internationally prefer to use partial productivity measures like labor or machine productivity. This is mainly because of the fact that the data needed for partial productivity measurement is easily available. Also, the result of productivity computation can be used by department head to evaluate the performance or to plan improvement. Let us try and understand how we measure output and input. As explained earlier, productivity is the relationship between the output and the input. The collection of data on the output and input therefore becomes extremely important. Output or input can be measured in physical units or financial terms depending upon organizational needs. Let us first try and understand how we measure output. Output may be measured as physical unit. Manufacturers producing a standard product tend to use physical unit method for measuring output. The output is measured in terms of number of items, maybe garments, produced. It could be an example of a 5-pocket jean or a dress shirt or any kind of garment. Next comes standard equivalent. In case of manufacturers producing products with close similarity, the output is converted into standard equivalent products for physical measurement. For example, if a manufacturer produces 3 different styles of shirts, each involving a direct labor content of 16, 20 and 24 minutes respectively. The shirt style taking 20 minutes is a standard shirt. The output of the other shirts with work content of 16 and 14 minutes will be multiplied by a factor 0.8 and 1.2 respectively to arrive at the output in standard shirt equivalent. Output can also be measured in terms of financial terms. In case of a manufacturer dealing with great amount of product variation, measurement of output in physical unit term may not be useful as the products are not comparable. In such cases, the output is measured in financial terms. Let us try and understand how we measure input. Labor input is generally measured in physical units like minutes, hours, days or months. Capital input like machines can also be measured in terms of time. All these inputs can also be measured in financial terms. Now that we've understood about inputs and output, let us move on to communicating productivity. As output and input are the important constituents of productivity, it is important that while communicating productivity, the output and inputs are explained clearly. It is often seen that productivity communication is incomplete or vague. In the apparel industry, it is common to hear statements like productivity of a factory is, let's say, 15 pieces per operator. The statement like this cannot be understood as the information provided is insufficient. It is vital to provide following information in productivity communication. Number 1, the form of input or output. For example, is it going to be a shirt or a trouser or a jacket, etc. Second would be quantum of input and output, asking how many, how much. The last and final option being the unit of measuring the input or output. Are we measuring it in time? A better and easy to understand communication can be to mention that the productivity of the organization ABC is 15 standard shirts per sewing operator per 8-hour shift. I repeat, 15 standard shirts per sewing operator per 8-hour shift. So it includes pieces per head of an operator and at what time and of what product and how much. So it is very important to mention correct unit when we express productivity. Let us try and understand it with the following example. A factory with 100 workers can have 4,000 standard hours of productive time a week at the rate of 40 hours into 100 workers. When all the factors mentioned above are applied, the total output lost comes to 1960 hours, which makes it to 49% of the potential. Let us now look into module 2, the measurement of productivity. In second module, we will learn about measurement of productivity, which includes productivity measurement methods, difference between production and productivity, levels of productivity measurement, how productivity is lost. First, let's look into the productive measurement methods. There are 3 productivity measurement methods. The first one being physical productivity measurement method. The second one being value productivity measurement method. The third one, value added productivity measurement method. Let's first look into physical productivity measurement method. This method uses the quantity of output and input as data for calculating productivity. Physical productivity can be measured in the following ways. Labor productivity, that is volume of output divided by volume of labor input. Material productivity, that would be volume of output divided by volume of material input. Next comes machine productivity, that is volume of output divided by volume of machine input. Another option would be calculating in terms of energy productivity, volume of output divided by volume of energy input. Total physical productivity, which would be total volume of outputs divided by total volume of all inputs. As you see in these formulas, name of the productivity depends on the type of input. The second option of calculating productivity would be based on volume. The first one being volume, and this would be value. Value productivity measurement method. This method uses the value of outputs and inputs as data for calculating productivity. Value productivity can be measured in following ways. Labor productivity, which is the value of output divided by labor inputs value. It could be calculated based on material, that is material productivity, value of output divided by value of material inputs. It could be calculated based on machine productivity, which is value of output divided by value of machine input. Energy productivity, which can be calculated by value of output divided by value of energy input. The final being total physical productivity, which can be calculated by dividing total value of outputs by total value of all inputs. The last option of calculating would be value added productivity measurement method. This method uses value added as data for calculation. where value added is equal to current income before tax plus personal expenses plus financial costs plus rent plus tax plus depreciation cost. Value added productivity measurement method is generally used in organizations that have highly diverse outputs or have very expensive raw material. Data for value added computation are taken from financial statements. Labor productivity can be calculated by the following formula: value added divided by labor input. Capital productivity will be calculated by this formula: value added divided by capital. Now that we've understood various measurements of productivity calculation, let us move on to production and productivity. Production and productivity are completely different terms. A company may have higher productivity and lower production, or vice versa. Let us try to understand the same with the following example. Let us take the example of Factory 1. Factory 1 produced 500 garments per day with 50 operators. So operator productivity is, how do we calculate it? It is calculated by the volume of output divided by the volume of operator input. So 500 divided by 50, correct? If we take up this particular formula, therefore one operator makes 10 dresses per day. The productivity ratio is 10 dresses to 1 person, or 10:1. Let us take another example of Factory 2. Factory 2 produces 675 dresses per day with 75 operators. When we calculate the operator productivity here, it would be calculated by 675 divided by 75. But wait, don't you think 675 is a higher production factor compared to Factory 1? If we go by this calculation, we get 675 by 75. The answer would be 9 dresses per day by one operator. In this scenario, the productive ratio is 9 dresses is to 1 person, that is 9:1. Isn't it obvious that Factory 1 is more productive than Factory 2, although Factory 2 has higher production? So, as we said earlier, production and productivity are completely different terms. The calculation of productivity in apparel industry is further explained by the following example. Let us take an example of a shirt manufacturing factory which has 105 machines, 100 operators, 20 helpers, 10 checkers and 3 supervisors. I repeat, 105 machines, 100 operators, 20 helpers, 10 checkers and 3 supervisors. The duration of a day shift is 450 minutes. I repeat, the duration of a shift is 450 minutes. The product that is being sewn and manufactured in the factory is a men's full sleeve dress shirt with a SAM value of 16.59 minutes for sewing. Now, the average daily output per shift is 2000 shirts. Value of the shirt produced is $6 per unit. Let us try and calculate the following. Let us try and calculate the operator productivity, the total labor productivity, machine productivity, total labor productivity in minutes per shirt, total operator productivity in minutes per shirt, and finally let us try and calculate productive efficiency of operators. Can we try and review the answer now? Hope you guys have calculated. Let me help you out. The calculation of productivity based on the above data can be done as follows. The first being operator productivity. How is it calculated? Let us reiterate the formula. Operator productivity is calculated based on volume of output divided by direct labor input, that is the volume. So, we have volume of output, that is 2000 shirts, divided by direct labor input, which would be 100 operators per shift. So, the answer being 2000 by 100. Operator productivity is 20 shirts per shift. Did you guys get it right? Next question was total labor productivity in sewing. The formula for the same would be volume of output divided by total labor input. So, we have 2000 shirts here and 130 workers. So, we should be getting 15.38 shirts per shift as labor productivity. Correct? The next question being machine productivity in sewing. Let me try and help you guys out with the formula. Machine productivity in sewing will be calculated by volume of output divided by machine input. So, the answer here would be volume of output is 2000 shirts per shift and the machine input. We were discussing about 105 machines, correct? So, 2000 divided by 105 is 19.04 shirts per shift. Let us come to the fourth question. Labor productivity. Labor productivity can also be communicated in terms of volume of labor inputs per unit of output, that is the shirt. In such cases, productivity will be calculated as below. Total labor productivity is equal to total labor minutes consumed divided by number of units produced. So, the total labor minutes consumed would be, we have 130 operators with 450 minutes. So, 450 into 130 divided by the units consumed, that is 2000. So, the answer would be 29.25 minutes per shirt. Let us come to the answer of the fifth question. Sewing operator productivity. It can also be communicated in terms of volume of operator inputs per unit of output, that is shirt. In such cases, productivity will be calculated as following. Total operator productivity is equal to total operator minutes consumed divided by number of units produced. So, here it would be 450 into 100 divided by 2000. The answer here being 22.5 minutes per shirt. Hope you guys got that right. Let's come to the next question. Productive efficiency of operators. The formula here is direct. Actual output attained divided by standard expected output. The formula, if we explain it even further, actual output attained would be SAM into units produced per operator. Standard expected output would be input in minutes per operator. So the way to calculate here is 16.59 into 20 divided by 450 minutes per operator. The answer would come as 0.73. When we convert it into a percentage, it is 73.33%, the efficiency. Next we come to calculate value productivity. Value productivity of a sewing operator is calculated by value of output divided by operator input. So what is the value of output? We convert that into the cost. We have 2000 pieces and we can convert it to the cost of one piece, that is 2000 into 6 US dollars divided by 100. So the value productivity of sewing operator here would be 120 US dollars per operator shift. Here you can notice that both output and input need not be terms of value to calculate value productivity. Now let us try to understand levels of productivity measurement. It is important to understand which productivity measure to use at a particular level of productivity measurement in an organization. Productivity measurement can be done at macro as well as micro level. The picture here explains various levels of possible productivity measurement in the apparel industry. Organizations with the presence of productivity measurement system do undertake regular productivity measurements starting from the plant level up to the operator staff machine level. Manufacturers in developed world may give more importance to labor productivity over machine productivity, whereas in a developing country with low wage cost, machine productivity may gain much more importance. Let us try to understand how productivity is lost. When one hears a statement that labor productivity of the company is only 50% or 60%, it comes as a shock. However, it is important to know that the 50% or 40% performance that is lost is contributed by various factors that individually may seem insignificant. However, their collective impact can be disastrous for the productivity performance of a manufacturer. The book Introduction to Clothing Production Management by Mr. Chuter, published in the year 1955, illustrates how output and as a result productivity is lost in an apparel plant. Take an example of a typical British clothing factory. Mr. Chuter illustrated how production potential and in turn productivity can be lost up to 49% due to factors which seems normal that are given here. In such a scenario, the annual labor turnover is 24%. Absenteeism of operators is at 10%. Methods effectiveness is at 90%. The average factory performance is at 90%. Repairs returned to operatives, that is alterations, is at 10%. Rejects is at 2%. Machine delay, that is idle machine, is at 1%. Machine delay due to other problems is at 4%. Unmeasured work is at 20%. Others repair time work is at 2%. Waiting time for pieces or for feeding is at 1%. Balancing loss is at 5%. Work study is at 1%. Let's try and calculate it in terms of actual numbers. A factory with 100 workers can have 4,000 standard hours of productive time a week at the rate of 40 hours into 100 workers. When all the factors mentioned above, that is, the percentages, are applied, total output lost comes to 1960 hours, which makes it to 49% of the potential. The figure here shows how these factors contribute to the loss of output in a clothing factory and brings down productivity. It is important to understand these factors and control them so that productivity is not lost to such a level. Let us understand the terminologies of lead time and inventory. Lead time basically refers to the number of minutes, hours, or days that must be allowed for the completion of an operation or process, or must elapse before a desired action takes place. Total time required to manufacture an item, including order preparation time, queue time, setup time, run time, move time, inspection time, and put away time. For make to order products, it is the time taken from release of an order to production and shipment. For make to stock products, it is the time taken from the release of an order to production and receipt into finished good inventory. Hope you guys are clear now what is lead time. Next comes inventory. Inventory refers to the value of materials and goods held by an organization to support production, that is, raw materials or sub-assemblies or work in progress. It could be for support activities, that is, your repair, maintenance, and consumables. Or it could be for sale or customer service, that is, merchandise, finished goods, spare parts. You have reached the end of this unit. To summarize, in this unit, you have reviewed productivity, different approaches of productivity, productivity measurement methods, and how productivity is lost in the apparel industry. Thank you.